Hi everyone, welcome back. In this particular video, we're going to take a look at a very important topic in terms of switching, which is a concept of VLANs, which stands for virtual LANs. What is this concept? We'll take a look at in this particular video over here. Not only will we take a look at virtual LANs, we'll also look at an aspect that is very, very closely related to virtual LANs, which is the port types. There are two types of ports that we'll be discussing in this particular video. We're going to be taking a look at your access ports and trunk ports. The main topics, as I just said, we'll take a look at the switch requirements within an office and a campus environment. We'll take a look at what VLANs are and how do they help us optimize our hardware. And then we'll take a look at the two types of ports on a switch that you configure once you have VLANs. So first thing, let's take a look at a typical network over here. I have an office building, a campus where I have two different departments. I have the sales department and I have the marketing department. Each one has its own network. Each one has its own switch, which connects all these PCs to each other. These PCs, this switch is also connected to the router. The router allows the PCs that are on this particular switch to exit in case PC1 wants to talk to PC5. It needs to go from my sales network, which would have a different IP subnet assigned to it. And the job of the router would be to connect to the other IP subnet, which might be 192.168.2.0. So for me to be able to connect my PCs from the sales department to the other department, I also need to put one of the interfaces on the router in the same switch. And on the other side, I would have another department which would have its own switch, which would have its own internal PCs connected to it, which is marketing department over here. And I would also connect it to the router. So the router would allow the connections between the two different switches, two different departments over here. All right, this is a typical environment over here, but this can lead to a wastage of ports on the switches. So for example, let's say this switch 1 that I have over here might be a switch that has 24 ports, which would have been sufficient for all the different devices that I have on this network. But because I needed to put the other devices on a different network, I ended up buying another switch for another 24 ports. All right, this is what we're going to avoid by using virtual LANs or VLANs. Okay, we'll get into that, but before we get into the VLAN concept, let me explain this to you over here. The office campus network will have multiple departments in their separate networks connected to each other using the router. So you're going to have 192.168.1.0 connect to 192.168.2.0 using routers. Each one of those networks will have its own switch, which allows the devices on the same network to talk to each other. Each network segment will require its own switch to connect devices to each other on the same segment, and the network segments will connect to each other using a router, as we saw in this diagram over here. This guy over here. So this is your switch over here for the sales department connected to router 1's E00 interface. This is another switch over here, which is for the marketing department, connects to the router over here. The router will allow me the ability to connect between the two different networks or two different departments over here. Now going back to my slide over here, this sometimes leads to inefficient usage of the ports as I explained. In this case, let's say we had a 24 port switch, which should be enough to handle the 8 PCs and the router in the previous diagram, but we need to segregate the devices into two different networks, so we end up buying two different switches. And that's the exact problem that VLANs address. So how does VLAN solve this issue for us? VLANs allow you the ability to break the switch logically or virtually into these virtual switches. So what I'm going to do with this is, rather than buying two switches, let's say I had 24 ports, what I can do is I can take one switch, one physical switch, which has 24 ports on it, and on that switch I can say I can designate certain ports to be part of two different virtual networks or two different virtual switches called VLANs or virtual LANs. So what I'll do is, because I want two switches, I'll create two VLANs. VLANs are identified by an ID, which is a numerical number. It is a 12-bit number. which gives you a total combinations of 496 VLANs. There's some VLANs that are reserved, but still a lot of VLANs for a campus network. So what I'm going to do is I'm going to create two VLANs over here. Let's say VLAN 10, doesn't have to be sequential, and VLAN, let's say 20. Once I create them on the switch, once I create these logical switches on my physical switch, what I next need to do is I need to assign the ports that belong to the sales department into VLAN 20, or sorry, into VLAN 10, and the marketing department into VLAN 20. So logically what I'm going to do is I'm going to take some ports from this physical switch and assign them. Tell them, hey, listen, you guys are in VLAN 20. I go to this port over here that is connected to one of the sales PCs, second PC, third PC, fourth PC, and the router. I go to those individual ports and tell them, hey, listen, you guys are in VLAN 10. So basically what I've done is I've isolated and I've created a separate logical switch which will have 5 ports in it. And one of those ports is my, oops, let's fix this. One of those ports is my router. Then at the same time, I have the other virtual switch for my marketing department. Again, I'm going to do the same thing over here, put all the marketing PCs and a port for what? The router over here in this segment. This is another virtual switch that I created with a ID of 10, a virtual LAN over here. So the PCs on red can communicate to the PCs on red using the same virtual switch, and similarly the PCs for marketing will be doing the same thing on this side. If they want to talk to each other, they need to go through the router to talk to each other. So essentially what I've done is, don't even look at it as a one single switch. I've done this, but virtually. And how do I do it? I need to designate the ports to be part of a particular VLAN, and that's where the port types come in. And we'll take a look at that as we go through this video. But before we do that, let's go ahead and finish up on the slide information. When you, by creating VLANs, you can allocate ports to these virtual switches within the same physical switch. When you assign the port on the switch to a VLAN, which I basically took those 4 ports that are connected to those PCs, it will only be able to talk to other ports in the same VLAN by default. If it wants to talk to any other port, it needs to go through the router, as if I had 2 physical switches. So compare this to this diagram over here, which is essentially the same thing. Because if I want PC1, PC2, PC3, and PC4 to talk to 5, 6, and 7, and 8, I would not be able to do it through the switch. I need to exit to the router. So that's what I've done. I've isolated the sales department and the marketing department from each other. The only way to connect them is using a layer 3 device that allows you to join 2 different networks to each other. Generally speaking, most of the time, one virtual LAN that I create, let's say I created VLAN 10 and VLAN 20, corresponds to an IP subnet. Generally, not always the case, but generally that's the case. So this switch, I'm saying this VLAN 10, this virtual LAN or virtual switch will have devices from 192.168.1.0, and this particular one will have devices from 2.0. Just like I've done over here, the only difference is it's not going to be 2 switches, it's virtually 2 switches, physically a single switch. All right. The VLAN simulates a switch, so previous configuration could be accomplished using a single switch based on the diagram that I'm going to show you now. So rather than having this type of diagram where I have 2 physical switches, I am going to create a single switch, and on this switch I'm going to create 2 VLANs. What are my 2 VLANs that I'm creating over here? VLAN 10 and VLAN 20. Once I create those VLANs, I'll go to the ports that are connected to those PCs. So for example, I have PC1, PC2, actually let me color them properly. I'll color them based on the color that I've given on this diagram. Color is just to give you a visual separation between the 2 devices, but it's the VLAN tag that I assign to the port. So what I'll do is I'll go to switch 1 onto this port and I'll tell it, hey, listen, this port belongs to VLAN 10. I'll have to go to this port, which is E01 on switch 1, say this port belongs to VLAN 10. Similarly, PC3, which is on port 4 of the same switch, I'll say that is in VLAN 10. Port 5 is in VLAN 10. And one of the router ports, which is E08, is in VLAN 10. So I've created a single logical switch which has 4 ports on it, which are ports 0, 1, 4, 5, and 8. 8 connects to the router, the other connect up to the individual PCs that are connected into the switch. Similarly, on the same physical switch, what I'm going to do is I'm going to go to this port, which is 2, 3, 6, and 7, and 9, and assign them to this VLAN 20. So logically, what I've done is I have created 2 switches over here. So this particular one will have port 2, port 3, port 6, port 7, port 9. So these are the devices that you're going to have, and then you also are going to have this port connect up. Actually, I should do it like this so it becomes easier. So logically, I have done this over here. So the red talks to green through the router, and that's what I'm showing you over here. So I can use a single switch to accomplish that, so I don't waste ports. Not only that, I now have the flexibility of tomorrow adding new ports to these VLANs as a need arises. So if I had more PCs joining into sales and marketing, I can always add more ports because I've only used up what 0 through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ports. So I still have 14 ports if it was a 24 port switch. So that's what you can do by creating VLANs. Now, the next thing over here is once I create a VLAN, a little bit about the VLAN, and then I'll show you how you designate the ports. The ports that belong to the same network segment will be assigned the same VLAN ID. So as I showed you, I would have gone to what? These ports over here, 0, 1, 4, 5, and 8, and I would assign them to VLAN 10. That would create that virtual switch with 5 ports on it. Similarly, I'll do the same thing for the other one and do that. If you don't do any of the configuration, any VLAN capable switch, like a Cisco switch, even if you don't create any VLAN, it still works based on VLAN concept. It puts all the ports by default into a default VLAN. The default VLAN, which all the ports belong to if you don't do any configuration, is VLAN 1. All right, this is also known as the default VLAN. Any Cisco switch that is VLAN capable would have all the ports assigned to this default VLAN of 1. In our example, the ports on the switch that connect to the PCs from the sales department, PC 1 through 10, and the router port in the sales network will have connected ports in VLAN 10. Similarly, PCs 5 through 8 and the router port in the marketing department will be VLAN 20. Any port can be assigned to any VLAN. They don't need to be contiguous. That's why I purposely did this over here. I spread them across. I don't need to do, let's say, the first 5 ports part of VLAN 10, the next 5 ports part of VLAN 20. Instead, what I do is I can pick any port and say, hey, listen, 0, 1, 0, 0, 0, 1, 4, and 5, and 8, these 5 different ports which are not contiguous are all part of the same virtual switch. So the main thread that stitches all these ports together is that VLAN ID. All right. Now, how do I do that? How do I go about attaching all these ports to each other? That's by configuring the ports. Which ports? If you take a look at this over here, this diagram over here, I have these ports that should be assigned to VLAN 10, 0, 0, 0, 1, 0, 4, 0, 5, and 0, 8. Okay? When I assign this particular port to a particular VLAN, that port which connects to an end device is known as an access port. Okay? An access port connects up to an end station, whether it's a PC, whether it's a router, or maybe a server, or maybe a printer. These ports that belong to a particular VLAN, a specific VLAN, are known as access ports. What I do is I will go over here on this particular port interface E0/0, which is this guy on the switch, and I'll tell it, hey, listen, you are an access port. The command for that, switch port mode access one line. I didn't have space, so that's why I did it like that. And then the second command over here, this is my first command. Second command would be to specify my VLAN. Again, one command, switch port access VLAN and 10. So what I'm saying is E00 over here is an access port with a VLAN 10. So I'll do the same thing on 01, I'll do the same thing on 4, 5, and the 8 port. So I'll attach, or I'll specify that the VLAN ID for these particular ports is VLAN 10. And when you do that, when you assign a particular port to a specific VLAN, on that particular port, you can only have one VLAN. That type of port is known as an access port. Hence the command switch port mode access. All right. So let's take a look at the access port definition. There are two types of ports on the switch. One we have just discussed briefly. The other one we'll discuss later on in this particular video. The first type is access port. The other one that we'll discuss later on in this particular video is a trunk port. We'll also talk about that. But for right now, let's focus on the access port. Generally, access ports are connected to either end stations or routers. The access ports can only belong to one VLAN at any given time. But if you don't do anything with the access ports or the ports, they will belong to one VLAN, and that one VLAN is the default VLAN, VLAN 1. Now, if you do want this port to be part of a particular VLAN, as I showed you, switch port mode access, you're telling it that's an access port and it belongs to VLAN 10. All right, simple enough. So I would need to do the same thing for all the other ports. Now on the switch, you do have the ability to group ports together using a command called the interface range command. Take a look at what I'm doing over here. In this particular configuration, what I'm saying is I want something to be done on all these ports. What are all these ports? I specify interface followed by this keyword range 00, 01, 04, 05, 08. These are the 5 ports that belong to the sales VLAN. Whatever commands, as soon as I do that, whatever commands that I'll enter, because I specify the interface range command, will be applied to all 5 ports. Now, if you're getting paid by the hour, you want to milk it, don't do it in this way. Go into each and every port and assign each port into that VLAN individually. This allows you to cut your time down if you want to go somewhere and you're in a rush. And this is a better way of doing it. You go in and specify the interface range command. You specify whatever I'm going to do now will be applied to E00, E01, 4, 5, and 8. And what do I want to do? I want all these ports to be access ports, and I want all these ports to belong to VLAN 10. All right. So once this is done, what happens with the frames that enter the switch? So as soon as I make this particular or these particular ports part of VLAN 10, let's take a look at that switch, and I want you guys to see what happens to the frames as they enter the switch when they're access ports. So what I've done right now, I have put these ports 00, 01, I believe 4, I believe 5, and 8. I made them part of VLAN 10 by using that switch port mode access, switch port access VLAN command. Now, these are my PCs over here. And then don't forget, you also have what? The other PCs that belong to VLAN 20. Now, when he does a broadcast or he sends any packet into the switch, as soon as it hits a switch port, which has been configured as an access port, and this access port belongs to VLAN 10, as soon as it enters the switch, when the frame is sent from the PC is not aware of this concept of VLAN. So it's going to send a normal frame with no VLAN information. But as soon as that frame is entering the switch, because the switch needs to make sure any packet, any frame that comes into this port should only be able to communicate to other ports in VLAN 10. What it does is it tags a new field on that frame. This frame would have had a source MAC, maybe a destination MAC, source IP, destination IP. This is what is received on this port. As soon as the switch receives it, it needs to make sure this frame can only go to ports in VLAN 10. So what it does, it tags it with VLAN 10. There's a VLAN field that is attached to this frame, and it is sent to the switch fabric. So these ports now are aware that they have the ability to receive it. The green ports will not process any packets that are not, or frames that are not part of its VLAN. So it can only go to the red ports. Now, the purpose of the VLAN tag is to make sure the switch understands that there's isolation done over here, that these ports over here can only communicate to what? Ports in the same VLAN. As soon as the frame is ready to leave an access port, because there's no use for the PC to segregate this traffic, because the PC does not understand the concept of VLANs. As soon as the frame is ready to leave the switch will remove the VLAN tag. So the PC always receives the frame as a normal frame with a source MAC, destination MAC, source IP, and a destination IP. So the VLAN tag field is just to make sure when the frame is within the switch fabric, it is isolated from ports in other VLANs. All right, and that's what I'm trying to explain to you guys over here. When an end station sends a packet frame to the switch will tag the frame with the VLAN ID. This tag will be on the packet or the frame until it leaves the switch on another access port. So if it leaves it on another access port, that has to belong to the same VLAN, because it will not be allowed to go to a port that is not in the same VLAN. The switch will remove the VLAN tag. So just remember, in terms of an access port, when the frame enters the switch, what does the switch do with it? Switch will add the VLAN tag, which will be done based on whatever you've assigned to E00. In my case, I've assigned VLAN 10, so the tag will be VLAN tag 10. It will stay on it until the frame is ready to leave towards the destination port. As it leaves it, what does this do? Before it sends it out, it will remove the VLAN tag. So remember this. Inbound into a switch, the tag is added. Outbound from that particular switch, again, from an access port perspective, the tag is removed. And that's what I'm trying to explain to you guys over here. And I'll give you a visual of the port types as well in the coming slides. The tag is removed when the packet leaves the switch on another access port. That belongs to the same VLAN though. All right. The tag is used by the switch to control the ports that the packet can access while in the switch fabric. So it's just a tag, it's a field that you use within the switch to make sure the packet is only allowed to go to other ports in the same VLAN. Because now I've created a virtual switch, and this tag is the one that makes sure my frames do not leak out into other, other VLANs. Now, just to give you a graphical depiction of it, let's say PC1 wants to communicate to PC2, the packet will look like this. When it leaves PC1, a frame will look like this. MAC for PC1, destination MAC for PC2, source IP, destination IP, and a data. As soon as the switch receives the packet, it will tag the packet with a VLAN tag of 10, which I'm doing over here. This just stays the same. I'm not touching it, but I'm forwarding the packets based on the MAC for PC2. All right. The tag makes sure the packet is allowed only to go to ports that belong to VLAN 10. I think we've established that already. Now, when the packet is ready to move towards PC2, which is on E01 based on our diagram, what does the switch do? The switch removes the tag, because the other PC does not understand what a tag is. A tag is just to make sure that the packet is unique within the switch fabric. So it again will remove it. Who did this? So inbound into the switch adds, outbound out of the switch, it removes. So it just has meaning within the switch fabric. There are certain places that you do want to maintain the VLAN tag, and I'll talk about that. But on an access port, the switch adds the VLAN tag inbound, switch removes the VLAN tag outbound towards the destination. All right, so that's how it works, and this is your graphical depiction of what the packet or the frame looks like entering within the switch fabric, exiting. So again, just to make sure, very important points that I'm making over here that I want you guys to remember as you go through your career in the networking field. So this is entering the switch. This is within the switch. And this is exiting the switch. Once it exits, it goes back to normal. So entering, it looks like this. The switch tags it, keeps it within the switch fabric. When it exits, it's back to normal. All right. Now this is the characteristic of an access port. Now the problem over here is, and let me give you a real life scenario for this as well. Let's say you had a building. Your company has multiple floors in this building rented out, or you own it. You have multiple floors, 1, 2, and 3 and 4. I have 4 floors over here. What has happened is I have a mixture of people that sit, maybe the sales execs, executive sales for sales, as well as marketing is over here. Maybe your some of the execs sit over here. Actually, take that back. So the execs for sales sit over here. Maybe some of the managers for sales and marketing sit over here. Maybe the sales exec, maybe the directors is putting different titles for different people on different floors. Now, what I want to do is I want the salespeople on the 4th floor, the 3rd floor, or the 2nd floor to be part of the same IP segment because they're all salespeople. All right, it's very tough to run the wire from top to bottom. So what I end up doing for each and every port, so what I end up doing is setting up one switch over here on this floor, another switch over here, and another switch over here. But because I have people from sales and marketing from each one of the floors, I will be creating 2 sets of VLAN. I'll be creating the VLAN 10 and I'll be creating VLAN 20 on all 3 switches, connecting the respective salespeople from the 4th floor, the 3rd floor, and the 2nd floor to these 3 switches. Now, in order for them to communicate to each other, I am going to connect the switches to each other. Switch 1, switch 2, and switch 3. I'm going to connect these 3 switches to each other. Now, once I do that, I need to maintain the VLAN tag. And by the way, these ports that connect switches to each other are called trunk ports. So trunk ports are generally the ports that are used to connect the switches to each other, but it has a very important characteristic. Now, understand something. If I have a PC over here on switch 1 that belongs to the sales VLAN, which is this guy, and I have another PC over here on the 3rd floor, which also belongs to the sales VLAN, they should be in the same VLAN. But what happens, remember what happens with an access port. When the frame was entering the switch, it added the tag. And when it exits, it removes the tag. So if I remove the tag on the way out over here on this port, this second switch would not know that this frame belongs to VLAN 10. So that's what the trunk port does for you. Its functionality, yes, it does connect the two switches to each other, but the internal functionality that it has is when a packet or a frame goes out of a trunk, it leaves the or comes in to a trunk, the switch does not touch the VLAN tag. It maintains the VLAN tag so that switch 1 can tell switch 2, hey, listen, this frame came in on a port that would belong to VLAN 10. So that switch 2 can take decisions based on that VLAN tag. It will only send that packet to the appropriate ports on switch 2 that belong to VLAN 10. And similarly, when the frame is getting forwarded to switch 3, because it's going over this trunk port connecting 2 to 3, I would need to maintain my VLAN tag so the frame will only be forwarded to the red ports on switch 3 as well. So just because I want to maintain my VLAN tag between the three switches, I will configure the port as a trunk port. What is the characteristic of a trunk port? When a frame leaves or enters a trunk port, the VLAN tag is untouched. It does not change, so that the other switch knows what to do with the particular frame. What VLAN does it belong to? All right. So that's what a trunk port does. So let's go ahead and take a look at the definitions and all. In a large network, you might have ports belonging to the same VLAN spread across multiple switches. So it's not on the same switch. You have one switch on floor 1, another switch on floor 2, but VLAN 10 has ports on both switches. In order to maintain the membership of the VLAN across multiple switches, the port connecting the two switches needs to send the packet frame without removing the tag. An access port, what does an access port do? Remember, what is the functionality of an access port in regards to the tag? It will remove the tag. If I remove the tag, the other switch will not know which port that particular frame belongs to on the other switch. So that's where the trunk port comes in, which is a very important functionality. The trunk port does not touch the VLAN tag field. So it doesn't add or remove it. It lets it go through. All right. It will neither remove the tag on the outbound nor add the tag on the inbound. It'll keep it as is. All right. What's the purpose of that? To extend my switch fabric from one switch to the other, to maintain my VLAN membership from one switch to another. All right. So that's what we do. And that's what I use a trunk for. Now, besides that, we'll also use a VLAN tag with an end device, and I'll talk about that in a later video in terms of why would I want to use a trunk port towards an end device. We'll discuss that in detail in a later video. For right now, based on the knowledge that we have, the purpose of a trunk port is to do what? The purpose of a trunk port would be to connect two ports that belong to the same switch to each other. Hopefully that's good, understood. Now, just to move forward with it, when you configure the trunk, the two devices that communicate to each other need to communicate to each other using the same frame format. Because normally, when you have an Ethernet frame, it does not have a concept of this VLAN tag. Now, within the same switch fabric, it was okay because it was within the switch. But now that I have two switches that are talking to each other, the sending and the receiving, it will have that VLAN tag. There are two different ways of configuring these ports to be a trunk port so that the format is understood by the other switch. There's a Cisco proprietary version of it called ISL. On its way out, most of the switches no longer are doing that. Even Cisco switches no longer use ISL. Their default is .1Q, and some of the new ones don't even use ISL at all. It's just .1Q. All right, .1Q is the preferred one. ISL is being phased out slowly. So even on Cisco switches, the protocol, the port communication that will take place, the format of the frame will be based on the standard, an open standard called .1Q, which allows us that ability to read a frame coming in along with the VLAN tag, because that's not a normal Ethernet frame. Ethernet frame would have started with what? The source MAC, destination MAC. This one has an extra field in it. So to understand that, I need an encapsulation, and that encapsulation is the trunk encapsulation that I'm going to use. Two main ones. One is the industry standard one, which is the one that you'll see a lot. ISL is being phased out. I just want to put ISL over here, so if you see it in an existing environment, you know that it is a trunk encapsulation. But as I said, phased out nowadays. How do I configure a port as a trunk port? Switch port trunk, encapsulation, and specify that I want to use .1Q, the industry standard one, and specify this is a trunk port in that order. So first you need to specify your encapsulation and then configure it as a trunk port. So if I want, let me go ahead and show you this diagram over here, and then we'll come back and take a look at the last item. So same type of configuration where I have 4 PCs and the router connected. But the thing is, I have my sales PC connected to E00 on switch 1, second PC connected to E01 on switch 1. On the same VLAN, PC3 and PC4 are not on the same switch, they're on a separate switch. Maybe these are two different floors. This is floor 1 and this is floor 2. All right? Everybody okay with this? Okay, so these ports on switch 2 are part of VLAN 10. Now I need to make sure when a frame comes into the switch, it will be tagged with VLAN 10 because this is going to be an access port. But when it sends it from switch 1 to switch 2, because there are ports, specific ports that these frames are allowed to go to, I need to make sure on the second switch it receives the frame with the VLAN tag intact. And that's where I would configure this port in the middle as a trunk port. So E04 doesn't have to be the same number, it just happens to be the same number over here as a trunk port. So when I configure it as a trunk port over here, I need to specify the trunk encapsulation. And as I said, nowadays the most common encapsulation you're going to have is the industry standard encapsulation of .1Q, and I need to specify the mode as trunk. And how did I do it? I showed you that command over here, switch port trunk encapsulation .1Q for that port, switch port mode trunk. Now the trunk port, once I configure it as a trunk port, will allow me the ability to carry the VLAN tag from one switch to the other, so the other switch now knows that this frame can only go to ports that are part of the same VLAN. You need to make sure on the second switch you use the same VLAN ID for the sales ports. All right, so now what happens to the frame as it goes through from one switch to the other? Just like I showed you what happens to an access port, let's take a look at over here. Let's go back to the diagram first. In this case, I want communication to happen between PC1, sales VLAN, to PC3, also the sales VLAN, but they're on two different switches. So when the frame comes in, and this is what I'm showing you guys over here, when the frame comes in, or when the frame leaves PC1, it'll look like this. MAC for PC1, destination is MAC for PC3, source IP, destination IP, and the data. All right. When the switch receives the frame, what does it do? It'll tag it because it came in on the port that is connected to VLAN 10 or has been configured as an access port. So E00 would have been configured as an access port in VLAN 10. So that's why when the frame comes in, it's going to tag it with VLAN 10. The rest of the frame remains as is. Now, because I need this to be forwarded to what? Switch 2, it will go over the trunk. The tag makes sure that the packet is only allowed to go to ports that belong to VLAN 10, but it so happens that the destination port belongs to the other switch. The packet will need to go over the trunk from switch 1 to switch 2 without touching the VLAN ID. So when it goes from switch 1 towards switch 2, neither switch 1 nor switch 2 on the trunk port will do anything with VLAN tag 10. So when switch 2 receives it, it sees it as VLAN tag 10, so it knows that this frame can only go to other ports that are part of VLAN 10. And that's exactly what I do over here. Switch 2 will receive the frame, just like this, the way it was sent. But now switch 2 knows that this can only go to ports in VLAN 10, and it finds out that the MAC address for PC3 is connected to port E00 of switch 2, sees it, says I need to send it to PC3, which is hanging off of E00 of switch 2. On the way out, it will get rid of the VLAN tag, and this is your access port. All right. So that's how communication works based on VLANs. And the important part to make the VLANs work, not just creating it, you need to assign the ports to VLANs. That's an access port. And you need to make sure you carry the VLAN tag across from one switch to the other. And that port is known as a trunk port. So just to recap, VLANs allow you the ability to create what? Logical switches off a physical switch to give you the capability of better utilizing the switch ports. Now, when you do that, how do I make sure the frames go to the appropriate ports on the switch? So what I'll do is I'll configure or show you draw two different switches over here. This is a trunk. In our case, it was E0/4 on both sides. And over here, I have PC1, PC2, my PC3 is over here, PC4 is over here. All right, so when the frame comes in, first of all, I need to configure this port as what? An access port, which belongs to VLAN 10. All right, this is an access port, belongs to VLAN 10. This is an access port. This guy over here belongs to VLAN 10. This is an access port, belongs to VLAN 10. What are these ports? Let's put some numbers over here. So let's say E0/0, E0/1, and on the other switch also I'm going to use the same ports. So these ports, E00, E01 on switch 1, are part of VLAN tag 10. E00 and E01 on switch 2 are part of VLAN tag 10. This is a trunk port running .1 QSD encapsulation. So when the frame comes in over here, in terms of VLAN, what action is taken? The VLAN tag added on access port. Which access port? E0/0 of what? Switch 1. So now it has that frame forwarded. Frame forwarded to whom? To switch 2 over trunk. No action on tag. So basically that means when the frame is getting sent over here, it's not touching the tag. So he knows the VLAN tag is 10. So on the outbound, on the access port, number 3, VLAN tag removed on which port? On the outbound access port. So if, for example, PC1 wanted to talk to PC2, it would be added with the VLAN tag of 10. It would remain with the VLAN tag of 10 within the switch fabric. On the way out again, it would have removed the VLAN tag. That's the way the VLAN tags work. On a trunk, maintain it. On the access port, inbound add, outbound receive, outbound remove. All right. We'll actually be implementing all this as we go through the video series for switching. But at this point, I want you guys to understand what a VLAN is, how do you assign ports to the VLAN, which is your access port, how do I maintain my VLAN tag as the frame gets forwarded from one switch to the other. That's your trunk port. All right. Hope you guys enjoyed it. Let's go ahead and get into the next topic, which is going to be VLAN trunking protocol, and then actually do the implementation of all the three things that we have talked about that we would have talked about up until that point, which is the first setup, which was setting up your switch, configuring the MAC address table, seeing how the MAC address table works, creating the VLANs, propagating the VLANs across, and then we'll do the VTP as well, which is the next video that I'm going to talk about before we actually implement this. All right. Thanks for watching. I'll see you guys again in the next video.